Yeah. Not too bad. Okay, so second half of 2.7, tying the whole chapter together. Beginning of the chapter we talked about rational numbers. We said we could write them as fractions. Well, the opposite of a rational number is going to be an irrational number. The prefix there, IR, irrational means not. Okay, so you got not rational number. If it's not rational, that means you can't write it as a fraction. And there's a couple types of irrational numbers. Any decimals that don't repeat. Most famous irrational number in the world? Pi. 3.14159, and I don't know beyond that. There was a Japanese man who memorized over 86,000 decimal places of pi.
There's that many?
There's an infinite number. Infinite number of decimal places in pi. Supercomputers have calculated pi to, like, billions of decimal places. And there was I think the world record's around 86,000 decimal places for pi. I mean, that's fantastic. That's great, grand, wonderful, but
Is it really?
I don't know. I'd kind of rather watch Monday Night Football, but that's just me.
That would take so long.
So decimals that don't repeat, we said earlier in the chapter, like 0.33333, sometimes people, 0.3 repeating, sometimes people go, well, that's irrational because it goes on forever. Yeah, but do we have a fraction for 0.33333?
Yeah.
What is it?
1/3.
1/3. So 0.3 repeating is a rational number, but sometimes you get decimals that go on forever, they don't repeat. That would be an example of an irrational number. Pi is the most famous one. And then you've got square roots of imperfect squares. Well, what the heck do you mean imperfect? Yesterday we talked about perfect squares. Somebody give me an example of a perfect square. A perfect square. 25, because the square root's nice, it's 5. What's another perfect square? 36. The square root's nice, it's 6. So can somebody give me an example of what they think would be an imperfect square? A number whose square root wouldn't be nice? Fish? 10. Like if I punched in the square root of 10, maybe. 10, square root. 3.16227766016838, and the only reason it stops here is because that's how many decimal places this little calculator shows. It goes on forever. There's no repeating pattern. That's an example of an irrational number. Okay? And then finally our last vocab word, real number. If we take all the numbers that we can write as fractions, so the rational ones, and all the numbers we can't write as fractions, the irrational numbers, put them all together, we have what's called the real numbers. All the numbers you guys have ever dealt with. And there are numbers that aren't real. They're called imaginary numbers, and you get a taste of those in your junior year, okay? When you're in Algebra 2. All right?
What do we take next year?
Next year you guys have the second half of this algebra textbook. So this year is all about linear algebra. Basically when we get into graphing, that kind of stuff, everything's a straight line. Next year you're going to get nonlinear algebra, so sometimes things are going to be modeled like this, like this, like this, like that, all sorts of different cool shapes, okay?
And then what do we take senior?
Senior year, by your senior year, you have to have 3 years of math to graduate. So 9th grade, you'd have the second half of this textbook. 10th grade, you'd have geometry. 11th grade, you'd have Algebra 2. So that would be enough math to graduate if you would like. But your 12th grade year, if you elected to take another math class, you could. Like if you wanted to go into some math field, or if you wanted to go to college, 4 years of math is a good thing. You could take statistics, you could take calculus, you could take, I think they even have like a personal finance class. Be kind of a cool one. All right, what do we got here? My little drawings. Okay, tell whether each of the following number is a real number. If it's a rational number, if it's an irrational number, if it's an integer or a whole number. We've seen a chart like this before. Let's just put X's in the correct boxes. Okay? Square root of 144, what is that? 12. I'm just going to indicate that. That might help us here in a little bit. How about negative square root of 49? What's that? Negative 7. And then we got the square root of 32. Is that nice?
No.
No, okay. It's going to be about 6. Yeah, very good. So how about this? Is 12 a real number?
Yes.
Yeah, and here's a hint. All the numbers are real numbers. All the numbers you guys deal with are real numbers. So we should automatically boom, boom, boom. Okay. Now, which ones are rational? Which ones can we write as fractions?
12 and negative 7.
12 and negative 7. How could you write 12 as a fraction? Riley?
12 over 1.
12 over 1, absolutely. 12 divided by 1. Same thing with negative 7. Okay? Or negative square root 49. I could write it as negative 7 over 1. Well, if it's not rational, what does it have to be? Yeah, why is square root of 32 irrational? Shower?
It's an imperfect square.
Imperfect square. It's going to be a decimal. It's going to go on forever, and it doesn't repeat. So which ones of these are integers? What do you think? Which ones of those are integers? Square root of 144, negative square root 49, square root 32. Are any of them integers? Shower?
The top two are integers.
Yeah, integers are like our counting numbers up on the number line. So 12 and negative 7 are also going to be integers. Decimals can't be integers. How about whole numbers? Anybody see any whole numbers up there? Tipka? The first two? Not quite. Conrad's? The first one. How come negative 7 or negative square root 49? Why is that not a whole number, Julia? Good. Whole numbers are 0 in the positives. Okay, 0 in the positives for the whole numbers. All right. Order the numbers from least to greatest. This is where estimating square roots is going to come into play. Okay, let's start with this. Let's just try to help ourselves out. What is the square root of 16? 4. What is 5 halves? Well, how many times does 2 go into 5? 2. What's your remainder? Half. 1 out of 2. So it's 2.5. So 2.5. What's the square root of 4?
2.
And then we've got negative 3. Now this one, I don't know exactly, but somebody ballpark it for me.
It'll probably be
What do you think the square root of 6 is going to be? Ballpark it. Mark?
approximately 2.
Approximately 2, maybe a little more, because the square root of 4 is 2, right? So the square root of 6, maybe a little more than 2. Let's call it 2.3. Doesn't have to be exact. But again, we're taking negative. So let's just ballpark it. This is, we don't have a calculator and we're supposed to put these in order from least to greatest. Yes, ma'am?
How'd you get 2.5 out of 5?
5 halves, if you take 5 divided by 2. 2 goes into 5 2 whole times, that'd be 4. So there's 1 remainder, 1 half remainder, 1 out of 2 is 0.5, okay? Now the reason I did this, the reason I wrote them all as decimals, when you try to compare things that look like square roots and fractions, and if they all look different, it's hard to compare them. Get them all looking the same, and now it's easier to compare them. Okay, we've got something going on at 4. We've got something going on at 2.5. Something going on at 2. Something going on at negative 3. Negative 2 point something, maybe negative 2.3. Well, now that I've got them on a number line, it's very easy to put them in order from least to greatest. But just remember, when you put them in order from least to greatest, we have to write them as they're originally written. So did they give us negative 3?
Yes.
Yes, they did. Did they give us negative 2.3? No. How did they give it to us? Not square root of negative 6. Very close. Square root of negative 6 looks like that. Yeah, they gave us negative square root of 6. Okay, just semantics, but there's a big difference. Did they give us 2? What'd they give us? Square root of 4. Did they give us 2.5? What'd they give us? 5 over 2. And the last one, did they give us 4? No, they gave us square root of 16, okay? But by converting them to decimals first, it helps us put them in order from least to greatest in the very end, okay? Let's have you guys try checkpoint problem number 3. I just want you to do the first part. Oh, there is only one part. Tell whether they're real, rational, irrational, integer, or whole. All right, so in number 3, Let's look at the numbers here. First of all, square root of 49. Let's do that. Let's tackle that first. Who thinks they've got the classifications for the square root of 49? Which square root of 49 is what?
7.
7. That might help us, okay? Who's got the classifications? Riley, shoot down the list.
They're all real numbers.
Okay, they're all real numbers, yep.
Right, that's right. And then it is rational.
If it's rational, can it be irrational? Uh-huh.
It is an integer.
Yep.
And it is a whole number.
Very good, very good. Who's got 0? 0, Taishana.
It's rational.
How can you write 0 as a fraction?
0 over 0.
Not 0 over 0. You can use
0 over 1.
0 over 1. 0 over anything except 0 because you can't divide by 0. So you're right. It is rational. If it's rational, it can't be irrational.
It's an integer and it's a whole number.
Integer and its whole. Very good. Negative 6/4, which, yeah, it's like negative 1.5 if you wanted to think of it as a decimal. Who's got that one? Shower power?
It's rational.
It's already written, yep.
Rational, and it's not a whole number. It's an integer.
Good. Okay. Negative 2. Conrad's.
It is a whole number. It is rational. It isn't irrational.
Mm-hmm.
It's an integer
Yeah.
and a whole.
Is it a whole number?
No.
Why is it not a whole number? Because it's negative. Yep. Whole numbers are 0 in the positives. Last one, square root of 17, which is not a perfect square. Riley, what do you got?
It is irrational.
Yeah. If it was square root of 16, which is 4, that'd be nice, that'd be rational. But 17 is going to be a decimal that goes on forever. And if it's a decimal that goes on forever, it can't be an integer, it can't be a whole number. Yes, Tipka.
What is the square root of 17?
Square root of 17, well, 16 is 4.
It's over 4.
So 4 point something.
8.
Yeah. 4.1-ish. That's the technical term. 4.1-ish.
4.1-ish.
Okay?
What was that?
All right. You don't have to use the number line. What I want you to try to do is put these numbers in order from least to greatest. Again, you don't have to use the number line, but if that helps you, you can do it. Put them in order from least to greatest. Okay, let's finish up. What is the least number up here? Taishana. Negative 2. What's our next least number? Julia. Negative 6/4, which is like negative 1.5. Then we've got Tipka.
0.
0. So we went there, we went there, we went there. Which one's smaller, square root of 17 or the square root of 49? Square root of 17 or the square root of 49? Sather? Square root of 17, square root of 49, 7 is our biggest one, okay? Again, we want to write them in order from least to greatest. Guaranteed, this is an easy point for you on the MCAs. This could be the difference between passing and not passing. One question, that's all it takes. You guys will nail a question like this, all right? That's all we've got today, rational, irrational. So we've got homework is...